Right, thank you everybody. The graveyard shift, beer calls, but the advantage of being last is it means I can refer to some of the earlier ones. What we've seen today is a number of recurring themes. Software, as we know, is now 50% plus of a vehicle. Safety and security, increasingly and more so, are key topics. I'm going to talk about software. So, hopefully, many of you, because we're automotive, know all about MISRA. But let's just remind us where we came from. So, Douglas Adams is always a good source for a quote. But far back in the mists of time, actually about the same time that NMI was established, MISRA was created. MISRA originally stood for the Motor Industry Software Reliability Association. I say originally because we've now been adopted by pretty much all the safety critical industries. And when you get people like British Aerospace saying, oh, we can't use MISRA because that's an automotive standard, requires a little bit of rebranding. Also, the medical industry quickly said, oh, is there an equivalent of MISRA for the medical industry? Well, yes, MISRA. So, who and what were we, or are we? Way back when, the group of the UK automotive industry got together, and this was led by the JLRs, the Lotuses of the world, and they created some development guidelines for vehicle-based software. This is when software was mostly still done in assembler. So, 1994. And having produced this wonderful book, they then decided, well, what can we do next? But that was the first attempt to produce some good quality software engineering into the automotive world. 10 years before 26262, actually a lot of the pedigree of that work became part of 26262. So, having produced a good bit of guidance, the what next, by now the C language had become a fairly integral part of the industry. We'd ditched assembler, we'd now started using this sort of semi-macro assembler that allows you to do all the clever stuff, allows you to do things, frankly, nobody should be doing. So MISRA C came along in 1998. Now, just to put this into a timeline, December 1998 was where IEC 61508 was published. And that, as hopefully you all know, is effectively the grandfather standard for functional safety. So what is MISRA or MISRA C? It's deliberately defined as a set of guidance. You can read it there, I'm not going to read it all out, but to help you not make the mistakes that the languages allow you to do. And increasingly more of the safety and now the security standards require that. So, 1998, first version, that was the automotive standard. The second edition, a few years later, notice the branding. This is now guidelines for use of C in critical systems. The Joint Strike Fighter project, which was kicking off at the same time, used this as the coding standard for the JSF. And that was almost a paradigm shift of where Ada no longer had the monopoly in avionics software. And it's largely because of this work. Now, this is all before my time, so I can, give the plaudits. But then I got involved, and we've incremented, we're improving, we're adding more capability. The MISRA guidelines, as I mentioned, then became ISO 26262, or particularly the software part. And there we have the well-known V model that those at the software side know and love. But I should emphasize, although 26262 illustrates with a V model, it doesn't mandate it. So those who are using Agile, who are thinking of using Agile, thinking of using any other method apart from a prescriptive V, that's fine. You've just got the principles you have to adopt. So how do we draw these two together? Well, it helps that many of the same people that created the original MISRA guidelines then became part of the ISO 26262 committee. Hence, the pedigree of that work moved forward into 26262. Many of those were also involved with MISRA C. So you have such requirements as in the guidance actually tells you that MISRA C is a good thing to do. It doesn't say you have to, but like many of these, this is a case of you should be doing this unless you've got a very good reason not to. And then we can build up on this. Do they go on? So 26262 software part tells you some of these things that you ought to be considering. The first one, enforcement of low complexity. If anybody's really bored, October the 6th, some person's doing a TechNest talk on metrics. How long's a piece of string is the title. And we'll talk about complexity in a bit more detail there. I only have 10 minutes today, so we'll skip that. But there it is, number 2, enforcement of a language subset. Guess which one you should be using? And many of these other techniques that are specified are actually the sort of ideas that MISRA is actually trying to encourage you to do anyway. So the dovetailing between the ISO standard and the MISRA guidance, it's there. And as we creep on, we've got the design principles, things you ought to be considering during your design phase. All of these are standard stuff, actually things that really as a software engineer you ought to be doing anyway. Sometimes I look at this and I think it's a pity we have to tell software engineers that they ought to be doing this. They should be doing it anyway. But again, this all maps into the MISRA rules. It's not a coincidence. Then we get into the implementation level of 26262, the things that you should be doing when you write your code. There's actually a pretty reasonable mirroring of MISRA rules to these. The top one is one of those where we can have some fairly deep and philosophical discussions. In the days of assembler, when you wrote your code, where you can jump randomly into bits of code, enforcing a single entry and a single exit, that actually made sense because we've had many allusions to spaghetti today. You can do that in assembler. Higher level languages, it's a bit trickier. Yes, you can have multiple returns, but in many ways, that's not a bad thing if you're using those multiple returns to validate your inputs. So we have some philosophical debates around that requirement and the corresponding MISRA rule. Dynamic memory. Again, it's a hot topic. Is it better to statically allocate big buffers, or can you dynamically allocate them? The issue is more of what you do when you finish with it, releasing it, and garbage collection, which in a real-time system is not such a good idea. So we've got a whole set of requirements in 26262 that map pretty much to the MISRA rules. So I've only got 10 minutes, so I can't really go into any gory details. But simply when we start testing, we've got these same checks that we ought to be looking at. Control flow, your data flow, again, we have these. And again, when you get into your integration testing, whole set of requirements. And a key bonus point here to show how influential MISRA still is within the ISO 26262 world. In the second edition, the whole validation part was restructured. It now is very much a unit test and an integration test. That was not an accident. That was very much driven by the MISRA group, where we have single translation unit rules for unit test, and we have system rules, which are for your integration and system test. So instead of having a three-phase split as the original 26262 did, where the split wasn't that clear, we got it made absolutely clear. So that's a fairly rapid run through of how MISRA and 26262 fit together. Anybody who's interested in this, please come and talk to me when I'm here for dinner or a few minutes afterwards out there. Contact details are on the slides. But what I'd like to say is MISRA, particularly MISRA C, but there is also C++ out there, is pretty much the industry de facto standard for high integrity, high reliability software. You know, it evolved out of the automotive industry, representative companies probably in this room, but is now pan-industry and global. So it's actually a real success story of the British automotive industry that's now global multinational. Thank you very much for your attention. I hope you've enjoyed the day as a whole, and maybe see you next time.